there is a ground floor is there. You can see here in AutoCAD here there is a mention plus 0.50 SSL. Means here the slab is coming, here also the slab is coming, here also the both are same. But if you see the other room, you can see this room they have mentioned here the SSL is 0.60. So you can think that from here the slab thickness is vary to here the slab thickness is vary. Like that, if you see this side also the floor thickness is varying. So this is ground floor. You can see wherever the slab thickness is changing, wherever the SSL value is varying, you can see the SSL value, how much the value has given. Here you can see 0.40 SSL. Here also you can see 0.50 SSL. Here you can see there also here. But rest of the area is coming this value 0.60. You can see here. This is the 0.60 value is for that area, remaining area. So each and every room you have to go through that. Now if you go first floor, you can see here the SSL value, you can see 4.40. So it is coming 4.40. So your SSL value is up to come 4.40. Like that, if you go second floor, you can see here the SSL value is 8.20. If you go again the top roof, you can see here there is also the SSL value is 12.00. Here also 12.0. If you go again the top, you can see here 15.00. So these all are the SSL value is considering for SSL for RCC floor. Okay, so now how we will create this SSL and FFL value to your project. So now you just go here. Now I am opening the project which I already discussed with you. The same project I am going to show you. This is the project. Just open it, go with editable. So now you have to measure it the thickness, because you can see the thickness of the floor. Now just go section drawing. You can see in section drawing they are going to provide you the thickness of the floor. There is some detailed drawing is also there, you can see. So with the help of the detailed drawing you can able to measure it the thickness of the floor. You can see here this is the thickness of the floor. This is FFL. Here this is the thickness for the FFL, but here this is the thickness for the RCC floor. So this floor thickness also, here some of the details drawing in the structure also given. You can see here. Here you can see this is the thickness of the floor. If you measure it from here, you can see how much the thickness is coming, including 15 centimeter plus 5 centimeter. How much? 220 centimeter. 20 centimeter means 200 mm is the thickness. This is the overall thickness of the floor. If you measure it from here to here, you will get the thickness of the floor. This is the floor thickness. Okay, this is the beam, this is the floor. Here also you can measure it. This is the floor, 15 centimeter. Below here there is a 5 centimeter. So how the floor is coming, you can see here there is some finishing. They have given all filled with well compacted some material they have given here. So this thickness they have taken separately, the above thickness they have taken separately. So like that, how the thickness they have taken here, we have to follow the same thickness here. So now 200 thickness means 150 is the concrete thickness. In between the concrete there are the reinforcement are coming, and below this is some plastering thickness concreting they have taken here. So the two layers we have to create in this way, this floor. Okay, so here they have given the details of the floor. You can see here typical TB section. TB section, this is the TB section, but apart from the TB section you can see there are floor thickness also they have mentioned here. So this thickness we have to consider for here also the floor. So if you measure it here, you can get, if you just map property this one, you can see 20 centimeter is the floor thickness. Or else if you go in section drawing also, you can able to check and measure it here, the thickness of the floor. If you measure it from here to here, here to here, you can get it the floor thickness. Just measure it. Where the dimension is given, the dimension is just measure it. It will become. Or else directly you can check it also here. You make it zoom out. So dimensional value you can see. Some 220 means below this one. It is going to take 200 means from here to here. divided by 1000 if you go, you just get it 200. So 200 is the thickness of the floor, this RCC thickness. So how this floor we have to place here, you just go here, workspace, you just make it on of all the workspace. Okay, and just take your center model file if you are working, so you just create one more workspace floor, and that workspace you have to put it S because editable, like that you have to work, because which task you are working, that task should be have the workspace. After that it will be going to become. Okay, so now already I have placed some 2-3 columns and 2 footings. Now I am going to place one more columns or footings like that, so you can able to get it the same. So when you are going to place the floor, you have to work out the structure plan only, because RCC floor is also you have to work out in the structure plan. So now you just go ground floor, and in ground floor you have to place the columns and footing the same. Sorry, footing you have to go. So same, already this footing plan already I placed, here also I placed. So now just for your information, again I am doing here the same way to work out the same structure drawing. You just open it. So here one more foundation we have to place. Okay, this is the foundation for here F8. F8 the foundation you have to place. So you just go here F8 and take the sizes of the F8, 420, 250, 650. Okay, so now you just go here and take the isolated structure, isolated. So go with edit type, duplicate, 420, 420 is the 4200. So already you have did, but for your information just I am doing here 250, 2500, and here 450, 650. Okay, 650 already is there, and this is the F8 footing. Okay, the same value I am putting here, 4200, this is 2500, and this is 650. Okay, now I am placing the footing here exactly as per the requirement of the drawing. This is the, so from here to here, this grid to this footing end 80 centimeter. Okay, so just go here, measure it. 80 centimeter means 800. So you just give the value 800, it will come here. Okay, so now again from here to here 125 means 1250. So again you have to measure it from here to here 1250. It is already there, correct. So this footing has been placed. Now in the footing there is a column. So here on column is coming, the column size again it is same. So you just go and place the column, take the size same C1, exactly you have to place it here. Sorry, column, take here height, and just go up to which floor you require, you just select it, and it is going to place here. It is going to place. So after placing this column, how it is coming? It is coming up to here. Am I right? It is coming exactly and touching middle of the footing. So you have to make it alignment. So you have to go align and just place it. So this column will be here. One more column is also there here. You can see this is also one more column. So from here to here, the column distance. So you have to go the column drawings again. You have to measure it the distance also. It will be get exactly how the value will be. So here 10 cm, 10 cm. So again go column, one more column you have to place here. Two grid. So one more grid you have to place from this grid to this grid. How much is the distance? 2200. So you have to place one more grid. Same process. 2200. Okay. So from here to here 10 centimeter. So you have to go 100. And from here to here 10 centimeter. You have to click 100. So this is the column, this one. Yes, perfect, it is coming. Here 150 is there, but you have to put 100. Because why I am showing this one? Because we have to create the floor as per the requirement of the footings and columns. Now one more footing is there here. One second, you have to go. One more footing. This is a big size of footing. F6. F6. What is the size of that F6? 580, 596, 650. So again you have to go here. Foundation isolated. You have to click F6. Duplicate. Now 580, 5800. And next is value 596, 5960, 60, and this is 6. This is F6. Okay, so same value you have to put here, 5800, 5960. This is 60. Okay, here you have to write the same. F6 means you have to write F6. Type mark, everything you have to work out the same, because just now I am showing you. Just click it. After clicking, now you have to measure it as per the distance. From here to here, this grid distance 2260. So here you have to go here to here, 2260, and from here to here 180. So DI, again just measure it. 180 means 1800. So this is the distance of dimension of this footing. Now here also you have to place the beam, column. So here one column, here one column, here one column. Okay, so now you have to go for the column drawing. So how much the distance they have given, based on the distance you have to work out the same. So now one column has to place here 10 centimeter. So again column, you have to place one column here between grid B. Just click it. One column, here also one column, here also one column. Again here also one column, and here also one more column. Okay. So now this column is from here to here 150, but we have to put 100, and from here to here this column distance is again 10 cm. It is touching, okay, not it is exactly touching this one. Okay, this is one column, and this column is also from here to here. What is the distance that's given? From here to here the center distance 2640. Okay, so now you have to align it first here, and from this grid to this column face is 26540. So just click it, 2640 you just click it. Okay, so this column also placed, this column also placed. Now this column is 20 centimeter and 10 centimeter. So now this column you have to make it flip. With the help of backspace you have to make it flip. So from here to here 20 means 200, and from here to here 10 centimeter. So from here to here 10 centimeter. 150 is there, but we have to keep 10 centimeter, 100. Okay, so this column also placed, and here there are two more columns. This column is coming here to here 40 centimeter. Okay, so from here to here this is 40 centimeter. So it is there 300. Now we have to make it 400. It is going to come here, and again 10 centimeter from here to here. 10 centimeter, 100. So this column also done. Now one more column is there here. 10 centi, 10 centi, both it is there. So now from here to here 10 centimeter, 100, and from here to here again 10 centimeter. fast I did, but I hope everyone has understood this one, because already earlier you have did this one. Okay, so for the creation, just I shown here. Now the columns and footing has been created here. Now I am going to the ground floor. In the ground floor I have to place the beam again here. Am I right? So beam also you have to go the same process, because after creation the beam, then only we can able to place the floor. Okay, so you can see here TB1. So already TB1 we have to place here. So you just go beam, ground floor, TB1. Okay, so last time I have did the beam. Not did, I think. Last time I showed you about the beam placement. Okay, I showed, but it is not saved, I think. Okay, no problem, I will do it also. Now you just go and place the beam, just load family, and you just select the beam. Here the beam will become, just make it duplicate. How much the size? You tell me the size. TB1, how much? 200 by 700, am I right? 200 by 700. And here you have to write the same way, TB1. Here 700, this is 200. And here you have to write TB1. So from this center to center, one beam has came. We have did something wrong. 200 by 700, am I right? The beam is correct. TB1, okay. Here the column size which I have given is correct. Column width is changed. Okay, so I think here the value, okay, here the okay, that day we have changed the value in global parameter, so that the reason he has changed. So just I am changing the global parameters again, because that day I have shown this one. So you just go and put here 300, 200 instead of 300, you just go 200, so it is going to be changed the same. Yes, now it's clear. Okay, so this column also, that is going to come up to here. It should be come up to here. Yes. There is a mistake, I think, because the column should become like that. So what is the value I have taken for here? 10 cm. Okay, this is 10 cm, 1360. From here to here, 10 cm. We should not take it as 100, and then from here. So this is also the same thing. You have to put 10 cm. Okay, now it's clear. Now we have to place all the beams here. Again, this from intersection point to intersection point, one more beam. Okay, again from here also you can check it here. What is the size of the beam? This side, ground floor, TB1, same size. Okay, so again you have to place the beam here also the same size. Here also you have to go intersection point to intersection point. Okay, or you can, if you click mid to mid also, it is not going to come, but you have to go intersection point, means from this mid to this intersection point. Here they will come, and here also I think from here to here it is 150, but it is 100. How much the column? 10 cm, 10 cm. what we have taken is wrong actually. From here to this grid 50, we have to put 100. So this beam is wrong. Again I am placing this beam. From here, from this mid to this beam. Okay, so now the beam is clear here. And here also we have to place the beam. Here the beam is TB2 from here to here. Am I right? This is TB2. Again, this is also TB2. Here also you can see here TB1. So this is TB2. So TB2, what is the size of the TB2? Tell me guys. How much the size? 600. Yes. 200 to 600. You just put here TB2. 200 to 600. And here you have to write TB2. Okay, so now again I think from here to here it is not matching. This value you have to check it again, this column. This one, how much this was? 1360. From here to here 1360 is not there, that's the reason. 1360 here. Now it's perfect. Now same TB2 you have to place it here. From this mid of the, here also some disturbance is there. Because it should become straight. Now you just measure it this value from this end to this grid 1310, but actually how much it should become? Okay, from here 2650. From this grid to this end 2650 should be there. So from this grid to 2650 2640, yes, 50 mm difference is there. 2640. Yes, now it's perfect. So you have to go here TB2 from this end to this middle. Let's place the beam. Again from here to here, one more beam. You can see here. There is one more beam is there, and that beam placement here is showing from here to here, then again from here to here. Okay, so like that we have to place here. Means this mid to this mid, again from this mid to this mid, it will become like that. So again TB2 from this end to this end, again from this end to this end. It will become like that. And if it is coming any gap, you just go and put the right click on that disallow joint. It is going to be touch. Again, if you are getting any gap, go with right click disallow joint. It is going to be touch here. It will become like that. Again, if it is coming in a gap, just go with disallow joint. It is going to be touch here. Okay. So this beams. Now, if you want to create a floor like that, you have to go. So now all the beams, you have to give the subtraction value of FFL minus 100. Am I right? Now you just go minus 100. So now for your, now this was created. Now you have to create the floor here, because now exactly the floor. So how much is the floor thickness there here? 600. Am I right? 0.60 means 600 meter. It is meter. It is there. Means from 0, the top of the floor will be 600. And what is the thickness of the floor? 200 mm thickness. Already I have shown you. So now you have to go structure, and here there is one option is there, floor. You have to go floor structure, not architecture. You have to go floor structure. Just click the floor structure, and you have to go here. There will be multiple floors will become here. Okay, so you can see here, this is the metal duct floor. Have you seen this one? This is the metal duct floor. Yes, this is the beam and block floor, and this is the all generic floors. And if you go here, you can see there is a multiple floors will be there. But you have to take the generic and just go edit type, duplicate, and you have to make the duplicate of 200 mm floor. So you just write here underscore, you just write here RCC floor, that's all. RCC, and you have to write here floor. So after putting RCC floor, you have to go edit and you have to click here preview. So in the preview you can able to see the floor, everything will be there here. So now what is the thickness as per this drawing only you have to follow, this structure drawing. You can see here 150 is the thickness of the floor, but below there is some concreting finishing will be there. So this finishing also we have to take here. So now here 150 is there, below one more level should come, but here you can see only one level. So just go here, click, and here one option is there, insert. Okay, so just go insert. Now you can see one more floor level has came, and this level you have to make it down with the help of down symbol. Now here you have to give 50 mm thickness. Now you can see the floor has been created. This is the 150 and this is the below concrete. So 150 is the finish of the concrete. This is SSL. This is the below as per this drawing. Now you can see here 150 this one means total here to here, green to green color, it is 150 thickness. This is the 5 mm thickness. Okay, so this 5 mm, this is, so 5 mm is nothing but 5 centimeter is nothing but 50 mm. So now you have to make it just this way. Now here if you are working with the LOD 500 or 400, so that time you have to add the material here, but right now you don't add it anything, you just go and proceed with this flow. So just go here, this 150 50 is going to become a 200, you can see here. So just these are the concrete floor, 200 thickness already came, and this floor we are placing interior, so you have to put interior. If this floor is placing exterior outside of the building, you have to take outside exterior. Okay, and remaining this all parameters you have to give it the same up to LOD 300. Okay, so same thing, you just go and make it okay here. Now you have to sketch the floor from where to where, from beam to beam. So with the help of line, rectangle, whatever you can take it, you can go with rectangle. So directly from this end to this end you have to sketch the floor this way. Okay, don't overlap here, you have to place this beam end to beam end, it is going to be touch, and like that you have to place. After placing you have to give the offset value here again minus 100 mm, because the finished floor thickness you have to give the minus value here, and just go with tick mark here. Now you can see the floor has been placed. So this is the floor you have to place here. So now you can see here in the drawing, this is the floor I have placed right now. Above this floor there is a staircase, but below there should be a floor. So like that you have to place the floor in this way. Now you can see if you placing one more beam also here, now I am placing one more beam also here, PB2, from this mid to this mid. Again it's not touching, just making measurement. So 50 is there, 100. So now I have one more floor also I am making here, end it to end. Now here also one more floor, this floor. Okay, the same process again, check structure floor, sketch it again from beam end to beam end, because each and every floor you have to do a sketch separately. Don't go like that, because after sketching complete one more floor I will sketch here, one more floor I will sketch like that. Don't go like that, because each and every room will be have floor separately, because if I click there will be a floor. But if I click here one floor, but there is multiple floors coming, don't do like that. You have to each and every room you have to floor, make it floor. This is one room, this is one room, this is one room, this is one room, like that. Where the beam is closing four side, that room we have to make the floor. Now here this is the corridor area, you can see this floor you have to make it sketch total up to here, total you have to make up to here. So this is only one floor, this total floor is considering only one. But if you come here, this is one floor, this is one floor, like that each and every closing area of the beam you have to make the floor. Okay, so after sketching you just give the value minus value and just put the tick mark. So here one more floor has came. Now you just go in 3D view, we can able to check how the floor has been placed here. You can see if you go with shaded, fine, and you just click here shaded, you can see the floor has been placed here. Okay, so this is the beam, this is the beam. The floor has been placed beside the beam. You can see, if you go see below also, you can able to see. If you go here in realistic material view, you can able to see exactly. This is the beam, this is the floor. The floor is touching the beam corner, and it is going to touch the top corner also, the same. Okay, this way it is going to be work out. Okay, got it? This beam also you have to make it subtract 100, because still I have not did, so I am just making 100 offset here. So this will be. So when I am going to cut the section here, now you can check it whether whatever the values of SSL has given, it is matching or not. You just go here, view menu, and there is a section menu is there. Section is nothing but front sectional cutting. So you just click the section view, put the section from here to here, and this is the range of the section. How much range you are going to see the view, so that view. This is the sectional. You just right click on that, go to view. Now you can see the floor, how it is going to be coming from 0. So now this is our ground floor, this is the footing level. Am I right? So how this floor is coming from here, this is the ground floor level. So ground floor, the thickness of the floor, the thickness of the, if you go above, there is the first floor, like that it will be. So now you can measure the thickness here. If you measure the thickness with the help of annotate, align, you can see this is the thickness of the floor 50 mm, and from here to here this is 150 mm. So 150 and 50 both are separate. It will become like that. And this is the thickness for the FFL. Again the FFL will become here, this area, this top, this gap, whatever the gap is there, that is there, because the ground floor is 0 level. So this is the way we can able to place the footing, floor in this way. So like that you have to work out here the same. Okay, got it? So how to place the floor? This is the way we have to place the floor. Each and every room you have to go and place the floor. Okay, so right now as per the drawings, your FFL level is the finished plinth level. Am I right? FFL. Just now I placed the beam, everything here directly in ground floor, but your level will be FFL. You can, if you go in AutoCAD, you can able to see the FFL level is there. So this level you are going to place the ground floor. Here it is the FFL is the ground floor. FFL is nothing but ground floor. So from FFL the floor will become, and there is a FPL level. So whatever the FFL level you have taken, that level you have to place the floor and beam. Here the FFL level is 700, but I have placed the floor in 0 level. That's the reason it is showing here in 0 level only directly. But if I taken this one in up to some 700 level, so it will become above level. It will be. But all the floor should be like that, because here 50 finishing will be, we have to give material. So later I will let you know how to place the material in the floor, so that time you just take. But how to create, you have to go edit tab, you just go edit, and here you have to create. So this is also structure, this is also, because this is also concrete, this is also concrete, both will be there. So the segregation you have to show like that, because right now we are working in LOD 300, so we have to segregate this wall, this floor. So everything we have to go, and segregation should be there here. So this thickness will be, you have to make it separate. Okay, don't consider single floor. You have to segregate the floor as per the below thickness, above thickness. Both you have to make it segregation and just do it the same thing. Okay, got it? So this is the way you have to create all the floors. So ground floor, first floor, second floor, every floor you just go and make it the creation this floor by subtracting the value of beam, FFL. How the value you have given for the beam, the same value you have to subtract for the floor also the same. Okay, so now you have to create this ground floor, total floor you have to create. Again, first floor also you have to create the floor. Here, from here to here, we have to sketch each and every floor. And again, second floor also you have to create the floor. Again, the roof floor also you have to create the floor. Again, in top roof also you have to create the floor. Okay, so based on that, you just do it and make it complete and show me tomorrow class, morning or afternoon session. You have to show me even one floor, you just do it practice and make it complete as per this drawing. Okay, clear? Okay, fine. So completion of this drawing. So based on that, I have told you everything. So for that reason, I have taken some time for placement this one, because you have to get the idea about to place the floors, level, everything. Okay, so if you go in 3D also, you can able to see the floor here. Like that, each and every floor you have to place this way. Okay, still the material we have to give it, but still material we have not placed. So that's the reason it is going to show you as like this, as a generic model, generic material it is going to show you. But always you remember, because your SSL and this floor should be same level. It should not go up and down, because above this SSL, again finished floor will become FFL. Again the tiles will become. So tiles we have to place separately, or else we can able to place here itself also. So I will show you that later. So now you just place the SSL only, SSL structure slab level, because the top of this floor is SSL from 0. Okay, so like that you have to create this one and show to me.